I believe that our current estimation of the mass of the galactic center is not accurate. In fact, it is just like according to the current understanding, current estimation, the mass of the galactic center is around 4 million solar masses. The central supermassive black hole in our Milkyway galaxy, according to the current belief, today we believe that the galactic center, the supermassive black hole in the center of our Milky Way galaxy, its mass 4 million solar masses. However, it is just like at the same time, we know that in our Milky Way galaxy there are 200 to 400 billion stars and their planets, surrounding planets, orbiting planets there. So if we take a median, 250 billion stars in our Milky Way galaxy, and this 250 billion stars are orbiting around the galactic center. According to the current belief, I am talking about according to the current belief, 200 billion stars orbiting a supermassive black hole in the center of the Milky Way galaxy, which weighs 4 million solar masses. This is absolutely a wrong idea, because always wherever you see, the central mass will be much heavier than the orbiting mass. For example, our solar system itself, 99 point more than 99% of the mass of the solar system is concentrated in the sun alone, the central mass alone. So this is in that way, if mass distribution, this kind of mass distribution only can provide a stable and balanced arrangement of for the mass. This type of mass distribution is very important to maintain system's balance and stability. If this is very funny to say that, actually it is a very blunt, I say, sorry to say that it's a blunder type, it's a big mistake. The scientists but that they made a very blunt error, very big error, that they are still, we are thinking that if you check encyclopedia, they are mentioning that. That is why I am telling about encyclopedia, online encyclopedia. That is because even now, at this moment, we believe that scientific community believe that the mass of the central supermassive black hole, the galactic center, is just 4 million solar mass. Now, at present, we believe that. Even now, this second, we believe that, and we propagate, we teach our children that the mass of the supermassive black hole in the center of our galaxy is just 4 million solar masses. Is absolutely wrong. Absolutely wrong. Because it is not possible. We know 200, and I am talking about, I am taking a median of our current estimation is 200 to 400 billion stars are there in our Milky Way galaxy. I'm taking a median, so I'm considering 250 billion stars are there in our Milky Way galaxy. These 250 million stars are orbiting around a mere 4 million solar mass. Is absolutely wrong. Absolutely wrong. It will never happen. It's a very much error. It's a big error. Still we are teaching our children that this is so. It will never happen. It's absolutely wrong. In fact, wherever you see in the universe, wherever you see in the any solar system, anywhere, this is not possible. If this is the case, the system will tear apart. If some large mass body orbit around a tiny mass, it will pull and go that way. It will never happen. It is absolutely wrong, that concept. So we need to check, we need to correct that thing. So now the question is, in fact, the answer of this question can provide a new insight about the dark matter. According to the current belief, dark matter share a major portion of the matter in the universe. However, I have a better explanation for dark matter. I believe that this dark matter, in fact, the missing matter in the universe is, we don't need to check anywhere else. I believe that the missing matter in a galaxy, we do not need to search somewhere else. It sits inside the galactic center itself. In fact, I think that we can compare our solar system and I'm talking about the mass distribution. The mass distribution in our solar system is just like the mass distribution of Milky Way galaxy is exactly same for exactly same as solar system, our solar system. That means our more than 99% of the total mass of the solar system sits inside the sun itself. If that is the case, this is applicable to our Milky Way also. So, I believe that more than 99% of the total mass of the Milky Way galaxy, it sits inside the black holes itself, the supermassive black holes itself. So that is a thing. It's a very, very interesting thing. So then only the galaxy will get a balanced and a stable structure or stable or framework, a stable frame. Otherwise, the Milky Way, it will tear apart. If some big, large, heavy mass body comes in one side, while it rotates, it will pull and go. It's absolutely wrong idea. So the question is, then why the stars orbits in a less speed? That is a flat rotation curve. Wherever which galaxy you see, you will see a flat rotation curve. It's not only applicable to our Milky Way galaxy. If you go to any galaxy, you will see a flat rotation curve. You know why? Because every massive body maintains a denser region of ether around the body. Yesterday I was talking about nuclear energy. In fact, nuclear energy mass defect is directly converted into a super thin form of matter. Whenever a mass defect happens, the missing matter is converted into a super thin form of matter. In fact, Einstein's idea of mass energy equivalence is absolutely another mistake. Mass energy equivalence is another one big mistake in our science, our current science and present day science. In fact, nuclear energy is released because of the change in the state of matter, just like a chemical explosive. We know that a chemical explosive explodes, and how a chemical explosion release energy. Liquid or solid state explosive material, when it ignites, when it oxidizes, it will become a superheated gas in a fraction of a second. So this fast expansion of the change in the state, for example, if a solid state chemical explosive or a liquid state explosive, it turn into superheated gas in a fraction of a second. So the vast expansion of the material gives yield the energy in a chemical explosion. In fact, now let's see about the nuclear reaction, mass defect in a nuclear reaction. For example, consider a fission reaction, nuclear fission reaction. If we see very closely, what we observe is that when a optimum energy neutron collides a uranium 235 92 uranium 235 nucleus, it splits and it produces two daughter nuclei and neutrons, alpha beta particles, and antineutrino like particles. So what we see if we see very closely, what we see is that when a fission reaction happens, there's a mass defect, and this mass defect, it explodes. It is just like a chemical explosion. The mass defect explodes, detonates. So this detonation gives a kinetic energy to the product particles, and when these product particles hits the surrounding particles of matter, it generates radiations, short wavelength radiation like X-rays, gamma rays. In fact, we cannot see any mass energy conversion in a nuclear reaction. Instead, we see only the expansion, mass defect, and the speed of the particle. When we closely observe a nuclear fission reaction or any nuclear reaction, for example, I am talking about a fission reaction. When you closely observe a fission reaction, what we see is that a mass defect, and this mass defect shoot the product fragments in every direction. That we see initially. That is the thing we observe. This is the thing we first observe. So once a mass defect happens, it shoots the product fragments in every direction. Then once these product fragments hit somewhere, it generates heat energy. That is the thing. In fact, many people believe that mass defect is directly creates photons. No, that is not correct. Many people, even scientists, many scientists also believe that. Today, people believe that a mass defect directly creates photons. No, absolutely not. Let me repeat again, because it's a very important point. Many of us believe, still even today believe that mass defect generates photons. That is absolutely not correct. That's absolutely wrong. In fact, when a mass defect happens, the product fragments or product particle gets high energy, kinetic energy, then when they collide the surrounding particles of matter, it generates, it emits photons. This is a fact. And not mass effect is not emitting or creating photons, generating not photons. It gives kinetic energy to the mass effect, gives kinetic energy to the product fragments, and when this product fragments hits the surrounding particles of matter, then it generates photons. That is a big big mistake we believe. So this is a thing. So when we closely observe a mass defect, this mass defect, it explodes, it detonates, and this detonation, that means missing matter is converted into a super thin form of matter, and this expansion or explosion gives kinetic energy to the product fragments, and when these product fragments hits the surrounding particles of matter, it generates heat energy. Now, another thing is that here, see the expansion ratio, the ratio of expansion, the speed of the explosion. When you compare when you nuclear explosion and chemical explosion, if see, for example, a chemical explosion, when a explosive ignites, it produces superheated gas, but the expansion rate is something like in a fraction of a second, it could be converted into a 10 cubic feet. For example, 5 grams of explosive material is expanded to, or it detonate to a 10 cubic feet of super. That means 5 grams of explosive material explodes. It becomes 10 cubic feet of superheated gas. That is the in a fraction of a second. For example, 1 by third second, or 1 by 10 second, whatever T and D high explosive materials are there. So in that case, it could be like 5 grams of matter turn into 10 cubic feet of superheated gas within in a 1 by 10 second. But interesting thing is, here is the interesting thing. But here, if you see the nuclear explosion, you know what is the thing? A gram of matter is converted into a gram of missing matter, produces a super thin form of matter. A gram of matter is converted into a kilometer volume of super thin form of matter in a millionth of a second. You got my point. Missing matter, 1 gram of missing matter produces a kilometer volume of super thin matter in a millionth of a second. So this is incomparable to a chemical explosion. This is a very huge explosion happening. So when this kind of detonation happens, the missing matter detonate into super thin form of matter, it gives a tremendous kinetic energy to the product particles, and when this product particles hits the surrounding matter, it generates thermal. When it hits the particle, it heat energy and produces X-rays, gamma rays, all such radiations. So that is the case. So either is not a new concept. It was a long history. Hundreds of years people believed in either. But in 1887, the result of Michelson model experiment, the interferometer experiment couldn't detect either. There's a reason for that I explain I upload multiple videos in my channel. You can watch that channel. Why Michelson model failed to detect either is a real thing. Even now many people are believing either. So either is a real thing. So I thing. I name this matter the super thin matter as ether, because it's ether is that name, that form of matter. We are since hundreds of years people believe that is. So I don't want to give a new name for this super thin matter, thin form of matter. I would like to give the same name either to the super thin form of matter. So in fact, every mass defect, whether in in our laboratory experiments, nuclear reactor, or particle collision experiment, or whether in a nuclear fission reaction, nuclear fusion reaction, stellar collisions, black hole collisions, neutron star collisions, all these create mass defect. In fact, a star is a producer, a large scale producer of ether. Mass defect, that mass defect is converted into ether. That's space filling super thin form of matter. So every mass defect in the universe release either or produce ether. So each star acts as a pump of ether. It's pumping ether. Pumping means that whenever a mass defect happens, it converts into super thin form of matter called ether. So every star in the universe, every collisions produces ether. So this ether is keep on producing. It is coming, always keep on coming into the space. So there is a source, space filling substance is there. Everywhere is there. So another important point, because ether is since ether is another state of matter, this particle, or if you take an individual particle of ether, it has all the qualities of ordinary matter. Because it is still is a form of matter, it has all the qualities of matter. Means if you take an individual unit of ether particle, it has mass. It can be attracted by gravity. So all the qualities, it has all the qualities. So there's a catch. So every massive body in the universe, because of the gravitational force of gravitational attraction, it holds ether region around it. The nearer the mass body, the density will be high, and it will reduce with the density of ether will decrease with the distance. So every massive body, Earth, stars, sun, black holes, neutron star, wherever you go, it has a ether envelope around it. Or you can say like this: every massive body sits inside an ether bubble. Please watch my previous videos. I published many videos talking about the same subject. Please watch that videos also. So every massive body has an ether bubble around it. So if that is the case, our Earth sits inside a ether bubble. Our sun sits inside an ether bubble, and the galactic center sits inside a gigantic ether bubble. So if that is the case, Earth's bubble sits inside the sun's bubble. Sun's bubble sits inside the galactic center's bubble. So therefore, ether is stationary. If you take measure the relative motion between, there is no relative motion between ether and Earth. So because of that, it is difficult to measure any speed difference. If you measure the speed in any direction, it will be same, because ether is stationary relative to us. So the Milky Way galaxy, center of the Milky Way galaxy, sits inside a gigantic ether bubble, and perhaps our galactic center's ether bubble overlaps with the neighboring galactic center's ether bubble. So these all are sitting inside ether bubble. That's why 2 days back I sent a note to James Webb team to consider that. I said like this: whenever you see a gravity lens, whenever you observe, because our James Webb telescope is very, very powerful, so you can see can detect many gravitational lines across the universe. So I said that whenever you see a gravitational lens, whenever you detect a gravitational lens, that means that is a ether bubble. Every gravitational lens is an ether bubble. So if that is the case, when light travels from one edge to the other edge of the Milky Way galaxy, it will be traveling through different ether density regions. In fact, gravitational lensing is a kind of refraction. Gravitational lens is merely a refraction. According to Einstein said that gravity creates curvature in space-time. That is not the case actually. In fact, my investigation says that gravitational lensing is just merely a refraction of light, because every massive body maintains a ether bubble around it. So the distance, it creates a density gradient of ether bubble. So when light passes near a massive body, because of the density difference, the light beam will get refracted. So that is the thing. So when a beam of light travels from one edge to the other edge of a galaxy, it will be traveling through many different density regions. So when a light beam enter into a denser region, a high optical density region, its speed will reduce. Just like a glass or a water, a transparent medium, when a light enters a medium, its wavelength will become shorter and the speed will reduce. So that is the thing. So when a beam of light travels from point A to point B, or one edge to the other edge of a galaxy, it will be going through a different density region of ether. So if you take if you observe the speed of light, it will be sometimes it will go up, sometimes it will go down, sometimes it will go again up. So when a light beam approaches a star, you will get a speed, less speed. But if you approach a black hole, it's very interesting. According to my investigations, says that why the black hole is black? Because a black hole is a super dense matter. So its density either near a black hole is very high. Therefore, when a light approaches near a black hole, because the density is super high, it completely stops. When a light beam approaches a black hole, since the density of ether is super high in the region, that will be completely stopped. That's why black hole looks like black, because the density of ether is so super high. So light cannot pass through that, because light will be stopped there, because the optical density is so high, the light will be stopped by the ether. So that is the thing. Anyway, thank you very much for my viewers. Please read my in this screen. I mentioned some very important, very interesting simple mathematics. You can read that. It's very simple mathematics. See, the current estimation of the galactic center mass is around 4 million solar masses. I'm reading the screen only. Please, I'm reading the screen itself, our screen itself. The current estimation of the galactic center's mass is around 4 million solar masses. The number of stars in the Milky Way galaxy is 400 to 400 billion stars. If you take a median, my median value is 250 billion stars. So 250 billion stars orbiting around 4 million solar masses. A simple math, 250 billion divided by 4 million equals 62,500. Now let's assume average mass of a star in our Milky Way galaxy is equal to our sun's mass. So the total mass of the orbiting stars is 62,500 times greater than the central mass. It is like an elephant orbiting around a rabbit. It is not possible. It's absolutely wrong. It's an absolutely wrong concept. I'm sorry to say that. Please, I request our researchers, you please consider this. Don't repeat the mistake again. Don't teach this mistake to our children. It's an absolutely wrong concept. So, in the coming videos, I will explain. Today I am releasing a video that explains the flat rotation curve, and it gives explanation for dark matter. What is dark matter? In the coming video, I am preparing a video. Probably today or tomorrow I will release that video. In that video, I am explaining what is dark matter and probably what is dark energy also. So it's very interesting. Thank you very much for my viewers. Very thankful. Thank you. Another thing I want to mention is that I am an independent researcher. I don't have any outside support. So if you like, you can support me through YouTube super chat, or you can share my videos. Please share my videos to your friends. So I'll get more views. So I'll get some benefit also. So I need that also. That is also very important, because I am an independent researcher. I don't have any external support. So you please support me. Please share my videos. Please subscribe my channel, and please refer to. Please introduce to your friends, and so please do that. Kindly support. I need your support. Okay. So anyway, thank you very much, my viewers. Please share because I think this video is a special video. It's a special video. I'm talking about something very interesting. So I hope you enjoyed the session. So kindly please share this video with your friends, and I would like to know their opinion also about this subject. So kindly support me. Another thing, I'm preparing a book. I'm writing a book. I hope it will be published soon. I am planning to publish in Amazon Kindle. So I will let you know when my book is ready. I'm preparing that. Hopefully it will be published in a very brief time. It will be published. So thank you very much. Thank you for support. Thank you for my viewers. And please share with your friends. Thank you. I'm winding up. I'm concluding this session. Thank you very much. Thank you.